Hi everyone, in this video tutorial we will learn how to simulate 3-point bending test of concrete specimen using Abaqus. We will use the concrete damage plasticity model for simulate the failure of our concrete material. We will also use our data and we will use our tools to extract the maximum force supported by our specimen, and also we will get the force displacement curve in our simulation. Let's get started. Let's start with creating of our specimen of concrete. Create part, specimen, 3D deformable solid extrusion, and 100 in size of our viewport sketching. Continue. Draw a rectangle and add dimensions 500 millimeter of the width of our specimen and 150 millimeter in the height. Click on and 150 millimeter in other dimensions. Now we have this specimen of concrete. Now we need to add some partition in this part. Let's create plans for partitions. Create that one plan, ZY plan, and add dimension 50 millimeter or 100 millimeter. Now I think we have a wrong position. Let's draw. Let's create a datum plan with 3 points. First, second, third point, and create offset datum plan from these on the value, flip direction, and click OK. 100 millimeter. Yes, this is the right position of this. Datum plan. Now let's create another offset datum plan. Click enter value and OK with 500, 400 millimeter. Now this is the right position. Now let's remove this plan. No. Or we need to go to this part and delete the features, this feature from, let's select that one plan, delete, yes. Now let's add some partitions in our part. Create partition, partition of cell, use that one plan, select that one plan, create partition. This is the first partition. Let's add partition in this cell. Select the cell, select that one plan, create partition. Now we have the right partition of our model. Let's go to create our pin for support and load pins in 3D discrete rigid solid extrusion. Continue. Let's draw circle. Add dimension radius for the circle 50 millimeter and click on 150 millimeter of the width. Now we have this part. Now we need to add reference point tool, reference point for this part, for this pin part, and we need to change to convert this part to shell part or to hollow part for rigid part. Let's create in this icon and create shell from solid. Click on it and select this part. Click done. Now we have the hollow part of the pen. Let's go to property module and we need to import concrete material from foreign library. Let's select the library, concrete, select the material, click import. Now we have this material in our library model. We have this material in our model. Edit material, density of concrete with unit ton per millimeter cube. This is the unit of density and also property of our material in megapascal for Young modulus and Poisson's ratio. And we have concrete damage plasticity property. We have this property of material. We have dilatation angle, eccentricity, and other parameters and factor for damage of concrete. We have concrete compression damage, and also we have concrete tension damage. Now let's create section, concrete section, solid homogeneous view, and select material. Click OK. Now let's assign this material to our part. Click OK. Now let's go to assembly module and create instance the first pin, and we need to add the second pin. Now select two parts, click apply, add other pin, apply, and also add another pin, apply. Now let's move these pins in the right position. The first one, click done, and move these points from this part to this point. Click OK. Now we need to move this part from this point to this point for supporting pin, the first supporting pin, and also this part. Click on this point to this point. Click OK. Now we have the right assembly of our model. Let's go to step module, static general, click and enable the nonlinear geometry for reason of failure analysis of our concrete. That's initial increment for calculating and maximum increment is 1. Okay. Now let's go to file output to enable which data we need to get from this analysis. Let's go to failure fracture. We need to get damage, 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 compressive damage, and tensile damage in our concrete. And also we need to get many others data I think let's select all. Now let's go to interaction module. Let's create our interaction property, continue, and select mechanical tangential behavior with friction coefficient equal to 0.5, 0.3, and also normal behavior with hard contacts. Click OK. Now we have create the property in contact. Let's add where is where we need to put this contact. Let's use this tool to find contact automatically. Click find contact pairs. We have three contacts. The first one between the load pin and the concrete specimen, and the second one between support pin and bottom surface of specimen concrete, and the third one is between the other support pin and bottom surface of our concrete with property we created before. Click OK. Now we have three contacts. Let's go there to edit, create edit. We have the pin surface as main surface, and secondary surface is the surface of our specimen. Now let's go there, and we have also the same things. Click OK. Now let's go to load. We need to, in initial step, we need to uncaster the two supporting pin. Shift, click the second reference point, click OK. Uncaster, avoid the movement in all directions and rotations also. And now we need to boundary condition 2, displacement rotation, click continue and select reference point of loading pin. Click done, and let's avoid the movement in all directions, but let's the movement in y direction free. Okay. Now let's apply the displacement to the load pin. In the step 1 displacement rotation, click continue, select reference point, click OK, and at minus 25 millimeter or minus 5 millimeter, 4 millimeter in this direction. Click OK. Now we have the right direction of our load. Now let's go to mesh module. And we need to mesh our parts. Yes. Let's select type and control our mesh. Click done. Let's add element addition and maximum degradation value 0.5. Okay. Mesh pin 10 millimeter also in the size of elements. Mesh discrete rigid element. Click OK. Now let's go to job module and create our job. Create concrete test. Concrete. Continue. Okay. Let's check our model. Data check. This operation takes time, but it's necessary before submitting our job. If we have any problems, we can detect and resolve before running our job. Check completed without any errors. Let's continue our process. Continue. Okay. Submitted. Running. Now we have completed job. Let's go to the result and visualization. Plot deformed shape and go to stress and strain. We have damage, intention, and compression damage. And also we have stress and strain, stress hormesis. Let's animate our result. Let's remove edges, apply, okay. Let's plot damage compression. Let's also show contours of damage intention. In the lower side, we have tension constraint and tension stress. This is our result of our simulation. Let's plot or create our force displacement curve. Go to ODB history output, click continue, and select this force and displacement in our. I think we don't select any value of displacement or reaction force. Let's go to ODB file output, click continue, and in unique nodal we need to get the displacement and reaction force. Let's select reaction force in y direction and also the displacement in y direction, these two value, and go to select the node. Let's select node set, select and highlight in the module. We have this point. Let's plot the result. We have this result of displacement and force. Let's go to build our force displacement curve. Let's save these data to as is name, click OK, dismiss, and go to operate on XY data, click continue, and combine operation between displacement, reaction force, plot expression. Let's reverse the curve, minus, and also add minus, plot expression, and we have the force displacement curve. Let's create another viewport and animation, and also create animation for this viewport. Let's create link it between two viewports. I hope to find many idea in our video. I hope to enjoy with this video and this simulation. Don't forget to subscribe in my YouTube channel and like this video. See you in another video. See you soon.